This is Math 6, Lesson 2-7, Misleading Graphs and Statistics. Companies often present data in ways that are meant to influence you. You will be able to make a better decision if you can carefully analyze the data. As you look at data displays, you might want to consider the following questions. Is the information shown accurately? And is the presentation meant to influence you? Graphs can be misleading in two specific ways. If the scale used is unequal, or if it does not start at 0. Statistics can be misleading when they do not accurately reflect the data that they are supposed to. Now you might ask, why would companies want to mislead you? They want you to buy their products, so if they can get you and convince you by showing you this phenomenal graph that their product is supposedly better than every other product, that will get you to buy it. So you need to make sure that you do your due diligence. Let's take a look at this graph. Look at the following graph. Let's examine it and explain why it is misleading. Water park patrons. At first glance, it looks like, holy cow, lots of people went to the water park on Wednesday and barely anyone went to the water park on Monday. It looks like no one went to the water park on Monday. But then if you take a closer look at the graph, you'll notice that they didn't start their graph at 0. They started it at 2,000. So literally 2,000 people went to the water park on Monday, and about, according to this, 2,900 people went to the water park on Wednesday. So really, it means 900 more people went to the water park on Wednesday than Monday, rather than looking at it Monday and saying, oh wow, it looks like nobody went to the water park on Monday, and 2,900 people visited the water park on Wednesday. Really, only 900 more visited on Wednesday than Monday. But the graph makes it appear that Wednesday was so much more crowded than Monday, when it was only slightly more crowded. So the scale doesn't start at 0. So it looks as if Monday had hardly any visitors. So that's one way in which graphs can be misleading. You always want to make sure that you look at the scale and say, did they start it at 0? No, they didn't. So in this case, it makes it very misleading. Okay, both of these line graphs show the high temperature Monday through Friday. Which graph could be misleading and why? If we look at the first graph, we can clearly see that each one of these temperatures goes up by exactly the same amount. 20, 40, 60, 80, 100. Goes up by 20 degrees, which means they started at 0 down here. Over here, we've got this little broken part, which means they're leaving out a lot of data, and that's okay as long as you're paying attention to that. It means they left out the temperatures from 0 to 60, and they started at 60, and then only counted by tens. So it makes it appear that the temperature change between Monday and Tuesday was much greater than it actually was, and between Wednesday and Thursday was ridiculously astronomical. Okay. 60 to 90 is a 30-degree temperature change, that is true, but here it looks like it's monumental, where here you can see it's definitely going up. Because these are the same interval, equal intervals, the graph on the left is a much better graph than the graph on the right. Okay? The graph on the right, this graph here, is misleading because it leaves out some data. Okay? If you look at it, since the axis doesn't start at 0, it gives the impression of a larger temperature change. Now these were line graphs, let's take a look at some other types of graphs. Let's take a look at some bar graphs, because bar graphs can be just as misleading as line graphs. It says, how is this graph misleading and what impression does it give? If we look at this, at first glance it looks like, wow, car B is 3 times more, at least 2 times more expensive, at least twice as expensive as car A. But when you look at it, car A cost $20,000, car B only cost $23,000. It's only $3,000 more. But it appears that car B is ridiculously more expensive than car A. So the gap from 0 to 20,000 is the same as the gap from 20,000 to 22,000. If you look at this interval right here, this interval is $20,000. This interval right here is $2,000, and it's the same amount of space left on your graph. This can be very misleading. So since you have the same amount of space and your graph doesn't start at 0, or it actually does start at 0, but you have the same interval from 0 to 20, from 0 to $20,000, as you do from $20,000 to $22,000. So it appears that car CB is much more expensive. Right. How much more money does car B cost than car A? Well, let's take a look at this. Car B is $23,000 and car A is $20,000. So that's a difference of $3,000. Not as much as the graph leads us to believe. Okay, let's look at some money raised by some 4th, 5th, and 6th graders. At first glance, it looks like those 5th graders have raised quite a bit more money. It almost looks like they have twice as much, maybe even 3 times as much as this poor little 6th graders do. But when you look at it, notice where our scale starts. Our scale does not start at 0, it starts at 530. Okay? So if we look at that, that means that our 4th graders, let's look at this, our 4th graders, the amount of money that they have raised is probably, it looks like about $558. Our 5th graders, the amount of money that they have raised looks like about $582 or so. And our 6th graders, the amount of money that they have raised is $550. So if you look at the length of the bars, how high the bars go, it looks like the 6th graders hardly have any money at all. But in reality, they only have $32 less than the 5th graders. So they don't really have as little money as the graph makes it appear that they do. Okay, since the scale doesn't start at 0, it makes it look like the 6th graders have hardly raised any money. This is why you need to really pay attention to graphs, because graphs can be very misleading. If the 5th graders wanted to make it appear that they are so much better than everybody else, they're going to love this graph. They're going to go, oh, look, we're beating you guys by a ton, but really they're not beating the other 2 classes by much at all. Let's take a look at these 2 graphs. They both depict the same information, the days of freezing temperatures in the year 2007 and 2008. If you look at the graph at the right, it looks like the days of freezing temperatures are very, very close. These 2 bars are almost the same height. If you take a look at the graph on the left, it appears that the days of freezing temperatures are massively different. So now we have to look at the reason why these graphs look so different. If you go over here, you'll notice it doesn't start at 0. We have 81, then 82, then 83, then 84, then 85. Here we start at 0, go 20, 40, 60, 80, 100, which means this is the better graph. This is the better graph by far because it shows a better representation of how many days that each year had that were freezing. It looks like 2008 had 84 freezing days and 2007 had 82 freezing days, which means there's only a 2-day difference between the two temperatures. Okay? So we need to make sure that we pay attention to the fact that the scale here doesn't start at 0. So it makes it look like 2008 was much colder than 2007, when in reality there are only 2 days that were below freezing or below in 2008 compared to 2007. Statistics can also be misleading. Statistics are things like mean, median, and mode. For example, the mean can be a distorted measure of data, especially if it contains an outlier. Let's take a look at 5 hourly wages. The 5 hourly wages are $5, $8, $7.50, $35, and $7. And no, that's not a typographical error. Why might the mean wage be misleading? Well, let's take a look at the mean wage. Let's figure out what the mean wage is. Remember, to find our mean, we have to add up all our time, or in this case, all our wages, and then divide by the number of wages we have. So we have to add 5 plus 8 plus 750. You might want to make sure you're lining up your decimal points here. $35 and $7. Okay. If I add all these up, let's see here. 5 and 5 is 10, and 14 is 24, plus 8 is 32, so I get 62.50, and I'm going to divide that by 1, 2, 3, 4, 5. Well, it said that 5, I should have known that. 5 goes into 6 one time, bring down my 2, 5 goes into 12 twice, times 2 is 10, bring down my 5, bring up my decimal point. 5 goes into 25 5 times, and 5 just goes into 0 0 times. So the mean wage then is $12.50. That's higher than every other wage besides the $35 wage. The mean wage is $12.50, and that's so much higher than every other wage except for the outlier. So the outlier has a huge effect. If you say, oh, everybody's averaging $12.50 an hour, the people that are getting $5, $8, $7.50, and $7 are going to look at you and think you're insane. Because they aren't making $12.50 an hour, but when you throw in the person who makes $35 an hour, it appears that everybody's making $12.50 an hour, which makes everybody look somewhat normal. Okay? So the outlier of $35 makes the mean wage go way up. This would be like saying, oh, let's figure out what your parents' average salary is, and we'll take your parents' average salary and your neighbor's average salary and the person down the street's average salary and an NBA star like, oh, let's say LeBron James's annual salary. His annual salary is so much larger than everybody else's. If we made and averaged them all out, it would make us all look like we're getting rich. When in reality, we may be just normal, average, everyday people. LeBron James is making so much extra money that his wage, because he's making, millions of dollars every year, makes us look like we're making millions of dollars. Oh, look, we made $455,000 last year. No, you didn't. Okay, because his wage made everybody else's average wage go way up. So this is how statistics can be misleading and how we need to be careful when we interpret them.